Observation skills. This is an invaluable skill that must be acquired by a researcher. The power of observation is developed through experience, coaching and mentoring. The data collecting methods and techniques are just the tools that help in systematic documentation. Observation skills strengthens the accuracy and reliability of the data. In Part 2 you have been introduced to the environmental cascade and cycles. This is a crucial aspect in coral nursery development as it is related to it. The study of ecological cascade and cycle is an awareness on how nature interlinks. A coral nursery is a replication of the coral environment with goals to replenish a damaged ecosystem. However, it is important to know what causes the ecosystem at the site to become damaged. To obtain this information, a site assessment must be carried out. A site assessment isn't only about finding out how much is damaged. Investigating what causes the damage is also important. Loss of coral colonies may be triggered by collapse of one or more elements in the ecological cascade. If so, rehabilitation of corals is not feasible until a solution is found on correcting the ecological factors. To find and identify the threats to coral requires knowledge on what to look for. This knowledge can only be acquired by dedication and experience in field observations. The assessment system. All environmental assessments must begin with questions and the steps taken to find the answers. Scientifically, this system is called data sampling. A process applied systematically to interpret what had occurred in the subject location. Elements of ecology. This step of observation is often overlooked as researchers quickly become dependent on instruments for data measurements. Observation of the ecological cascade rarely requires sophisticated equipment. Instead, the observer must have understanding of the ecology and making physical observations through noting. In some geographical locations, the ecological cascade is intact and it does not need any restoration. This is rare as many locations has been affected by global impacts. Nonetheless, it must not be excluded from the observation. Then there are environments that has undergone transformation, either degradation or a rebound from a devastated state. These are all elements of ecological cascade that can tell the observer if intervention is needed in the location. Observation of ecological cascade include evidence on the reef. A general observation of how much degradation, if any, had happened in the area by comparing what remains and what has been destroyed. The period of events can also be estimated through the visual appearance of the reef. Other evidence is the abundance and diversity of resident marine life. Grazers like parrotfish and rabbitfish plays important role in keeping algae infestation in check. Farmers like damsels maintain a healthy balance of sustenance demands of the grazers. Predators will remove the weak and sick organisms to keep the ecology healthy. Scavengers will consume dead organisms and maintain ecological health. Their presence are links in the ecological cascade. If one or more of the residents is absent, it can be an indication and it demands attention. General state of health of the corals. As the observer pass over the reef, they take note of the state of health of the corals. During this observation, an underwater camera can be used in documenting section of reefs. The visual account also includes general appearance of the reef, a comparison of dead areas versus living colonies, number of colonies infected by disease, parasitic activities like the infestation of Drupella snails, signs of new recruitments, toppled and damaged colonies, evidence of damage from human activities. diversity of corals. The observer takes note of the different variety of corals and document them through photography. This is not a biodiversity survey. The assessment is to see if the reef is dominated by a single species or mixed of different corals. Vast fields of a single species cannot be accepted as a healthy coral reef. A healthy coral reef should demonstrate diversity in corals and the marine organism living there. Detailed biodiversity survey can be done at later stages of the project. Observing coral diversity includes depth of observation. This is necessary as different coral genes and species often found in specific depth zones. This ranges from the intertidal areas to the edges of the continental slope. Type of substrate they are found on. Some corals are found on the side of cliffs, while others can be found on the sand near the reef edges. Density of coral cover. The observer must take note of the distribution and type of seafloor where the corals are found. Density should portray how much of the seafloor is occupied by the corals. In some geographical locations, massive corals' heads are found sporadically spread on flat sandy seafloor. The age of this type of reefs can be observed on how the colonies are packed together and their size. Evidence in the water. This is an element that the observer come in direct contact with. Evidence in the water allows the observer to use all their senses as they are surrounded and immersed in it. At this point of observation there is no need for measuring instruments. Instead, the observer feels their surrounding and describe it. Evidence in the water include clarity, temperature, color and odor. Evidence on shore. Many evidences of presence of large reef systems can be found on shore. Rubble embankments on shore contains valuable information of the ancient and recent reefs nearby. Evidence on shore also provides source of information of the past coral diversity as compared to the present reef environment. By looking at the variety of dead coral skeleton on shore can give the observer an idea of the number of species once thrives there. Training to look for this indication is important in the development of the observer's ability to interpret these environmental information. In later stage, the history of the corals in the area can be told through skeletal taxonomy. Because of this intricate connection, the assessments for a coral nursery development are not confined to the observation underwater. Observations on shore is as important. Many threats to the coral nursery also originated from the shore. Pollution and runoff from breaking streams during monsoon also threaten the corals. Systems of observations. While general observation can help define the ecological factors, there are aspects of data gathering that can help prove or strengthen the observations. This is done through quantifying, gauging and measuring the components and makeup of the ecology. This far the system of observation only requires simple tools like slate, pencil, compass and a mean to measure depth and distance. The system used to document these observations are divided into two categories: quantitative and qualitative. Quantitative observations are techniques, tools, and instruments to establish quantifiable data such as estimated density of coral over specified area, estimated diversity of coral within the research area, estimated growth over a period of time, estimated loss over a period of time, size of an area. These are examples of many quantitative data uses. Qualitative observations. These are techniques, tools, and instruments to establish a measure of quality against known benchmark values. It includes water quality analysis and interpretation, behavioral analysis, state of health analysis, These are all the observational skills needed when making initial assessments for coral nursery development. Now you are introduced to how observation is made. In the next chapter we will apply the tools and techniques of data gathering.